Welcome again. In this week, I will present minimum variance and deterministic controllers. There are two topics. One is the class of minimum variance controllers and then deterministic controllers, which will include Smith predictor and internal model controller. We will present the J step ahead prediction error model for noise models of this type. We will obtain the estimate y hat of n plus j given all information up to n with j greater or equal to k. We will do this by obtaining Ej and Fj through long division, for example. We will then move on to minimum variance control, in which we will replace j with k, which is the plant delay, and arrive at this simpler model, and we will equate the right hand side to get the minimum variance control. This is used as a benchmark controller against which the performance of other controllers are compared. We will then move on to generalized minimum variance control, in which we will try to get an approximate minimization of the index given here. Although it is approximate, it is very popular, especially amongst the Japanese researchers. It is used in adaptive control, to tune PID control, and so on. We will then shift gears and move on to a somewhat different topic. We will come up with Smith predictor to handle time delays. This is the configuration that we will arrive at. Basically, what we get by this dotted line is to get rid of the time delay, get an estimate of the plant without the time delay. Using a similar idea, we will come up with internal model controller for stable plants. You can see that this configuration is somewhat similar to what we saw in the previous slide. We will call this as the internal model controller GQ. In a configuration like this, there are many benefits. For example, we can show that the system is internally stable by choosing GQ also to be stable with the help of this matrix transfer function. We will try to get GQ equals G inverse, because under this condition and if GP equals G, we can get the plant output to be 0 for regulation problem, that is for disturbance rejection problem. This is another important property of internal model control. In order to achieve this, we will factor our plant in this manner so that we will get an approximate inverse of the plant. We will also obtain relations between the internal model control and standard controllers that we have been dealing with until now. We have exciting topics here for this week. I would want you to join me in learning about these. Goodbye.